Hey everyone, it's Justin again. This help video is going to provide a walkthrough of the second practice problem in the solving triangles lesson involving variables m, n, and p. If you are unable to answer this practice question, or you just don't feel confident in your understanding of the content, this video is going to be helpful to you. So in the second practice problem, you were asked to solve the triangle below. Where needed, round angle measures to the nearest degree and side lengths to the nearest tenth. We're given a triangle with two known side lengths and a right angle. When it comes to solving triangles, there are many different ways that you can go about it. However, I recommend that you only use the given information to solve. By only using the given information, you eliminate the possibility of incorrect answers due to rounding. We could solve this triangle in any order. Let's just start with P first. We actually don't need to use trig at all to solve for P. I have a right triangle with two known sides, so I can just use the Pythagorean theorem here. First, I will substitute my values in for A, B, and C. 9 and P are the legs of my triangle, so they're going to go in for A and B. Remember, it doesn't matter which leg is A and which leg is B, so if you just substituted these in the opposite way, that is totally fine. Then my hypotenuse is 23, so I substitute that in for C. Now I can simplify this, subtract to get P squared alone, and take the square root of both sides to get P. I don't need to worry about simplifying my square root since I'm just going to give my answer as a decimal. I can just put the square root into my calculator to get the decimal approximation, and then round to the tenths place. So my final answer for P is 21.2. Let's move on to N next. This time we do need trig, inverse trig in fact, since we need to solve for an angle measure here. 23 is the hypotenuse of this triangle, and from N, 9 is the adjacent side. The trig ratio that uses the adjacent side and the hypotenuse is cosine. I can set up my cosine equation to give me this, and then I can rewrite this equation using inverse cosine to be able to isolate n. Now I can put this expression into my calculator, which gives me back a decimal approximation for n. Based on the directions, I need to round this to the nearest degree, so my final answer for n would be 67 degrees. And with that, we have one variable left. Solving for m is going to be a very similar process involving inverse trig. We'll start by relabeling our sides. 23 is still the hypotenuse in this triangle, and from m, 9 is the opposite side. The trig ratio that uses the opposite side and the hypotenuse is sine. I can set up my sine equation to give me this. Like last time, I could rewrite this equation using inverse sine to be able to isolate m. Now I could put this expression into my calculator, which gives me back a decimal approximation for m. Based on the directions, I need to round this to the nearest degree, so my final answer for m would be 23 degrees. I'm going to put all three of those answers in my triangle just to give you the full picture here. As I mentioned earlier, this is just one way to solve for these three variables. You could have taken many different approaches, but they should all give you 21.2 for P, 67 for N, and 23 for M. For all three example problems, there is work shown in the answer key for every possible method of solving. So no matter what approach you take, you should be able to check your work against the key. Good luck on the rest of your practice.